Okay, so now I will be going over question 8. So, in order to show question 8, I'm going to do a proof. Okay, so starting with the concept of force is equal to mass times acceleration. Okay, so acceleration is equal to the derivative of velocity. So acceleration is the change in velocity with respect to time. So now I can plug that in to here and do force is equal to mass times change in velocity with respect to time. So I can say that force is equal to, I can put it in there with respect to time. And then momentum, which is expressed as P, is equal to mass times velocity. And as you see, I have that there, so I can plug that in and say force is equal to change in momentum with respect to time. Then I can multiply that, and I can get force et is equal to dp. Okay, and so now I can take the integral of that. So I can say that the change in momentum is equal to the integral, taking the integral of both sides, of force with respect to time. And then if I do that, the change in momentum is equal to impulse. So I can write impulse. And impulse is expressed with a j. So I can say j is equal to the integral of force with respect to time. So if I rearrange that, I can say that the average force, so for force average, is equal to the impulse over time. So that is the important proof that I have, that I need for this problem. Average force is equal to impulse over time. And so that will be important for this problem. And then one last concept I'll go over really quickly is in this problem, it deals with an elastic collision, and basically an elastic collision is where both momentum and kinetic energy is conserved, so no energy is lost in the system. The 1/2 mv squared initial will be the 1/2 mv squared final. This is very uncommon, or extremely uncommon. It almost never happens, but in terms of this problem, that's what it means. Okay, so now I will be reading question 8. A ball of mass m is dropped from rest from a height h and collides elastically with the floor, rebounding to its original height. So, since there's no kinetic energy being lost, it will rebound. You'll have the same energy, so it will rebound to the original height. What is the magnitude of the average force applied by the floor on the ball during the time the ball is in contact with the floor? Okay, so basically this question is asking for the amount of force applied on the floor. So what I've shown in this proof is that the force average is equal to impulse over time. And so that means in order to find the average force, I need to know the amount of time. However, in this problem, it doesn't give me the amount of time. So that means I won't be able to solve for the average force. So that means that the correct answer to this problem is E. And that's because in answer E, it says it cannot be determined without knowing the length of time that the ball is in contact with the floor. So basically that's just showing this principle that I've gotten at, is that if I don't have time, then I can't find the average force. So usually the answer are not those types of answers, but in this case, I don't have time, and this is the principle that I've shown. So, in conclusion, this video shows an important concept that the average force is equal to impulse over time, and you need those things to find the average force. So if I don't have time, then I can't find the average force. It also showed a case of an elastic collision where there's no kinetic energy being lost to the system, so of course it will rebound to its original height.